Hi, this is Mark from Waveformed, and welcome to the second in our two-part series on Gainstaging. So let's do a quick recap on the basics. So you can see in the project here we have three samples pack loops. So there are three drum loops, and you can see from the waveforms that all three are in or around 0 dB, so as loud as they possibly can be. This is because they have to compete in a marketplace where everything is loud. So you can see when the indicator there lights up blue, that means we're gone over 0 on the individual track, and on our master track you can see we're flashing red, so we are going over 0 dB and clipping. So we can select all three tracks, so we want to reduce at source, so that's the first available opportunity. We want to set the correct level. So we drop down by 10 dBs. Now our levels are much more acceptable. So what we want to do is, again, set our correct and appropriate level at the source, the first available opportunity. So we could also, if we were being lazy, you could use a utility, but it would be better to use the individual clip gain. So if we add any processing to that track, we've got to maintain the exact same level to maintain correct gain structure. So you can see we've got about 1 dB of gain reduction, and we've got about 1 dB of makeup gain. So no difference between the effect on or off. So in essence, gain staging is pretty simple. All you do is set the correct level as early as possible and maintain that throughout your signal flow. So here's abusing that incorrect gain staging. So boost massively in our compressor and reduce on the output of our warm tube. So you can hear distortion and basically poor audio quality. Okay, so I'd like to look at the psychology of the fader. So what do I mean by that? So you can see we've got 0, -6, -12, -18, quite large gaps, and then smaller as we go lower and lower. So that's a little bit misleading. So again, most people labor under the misconception that you've got to be hitting very close to 0, so somewhere between -6 and 0. If you do that with every track, you've got no space, no headroom, and your mixes are going to be very poor. So let's just look at an example, one track. So we'll play back some piano chords. So it's at full volume, and we can see we're peaking at around -1. Fine if the track's on its own, but in a mix it's going to be way too loud, so we've got to reduce our level significantly. So to do that, of course, we come down to our clip gain. So again, we're setting our gain level at the earliest possible stage at the source. So we're going to drop that down by about -12 or 13 dBs. Now you can see our level is not even going halfway up the fader throw. So we're leaving ourselves plenty of headroom. So there's no need to aim for 0 dB on any of your tracks. Yes, you can go over 0 dB on the individual tracks because of Ableton's inbuilt 32-bit processing, but there's no point because you have to come back down to 0 when you get to the master track. Okay, so another very important psychological aspect to be aware of is the difference between a raw mix and a master track. So it's impossible to compete with a commercially mastered track if you're mixing because you're a stage behind. So here we've got a raw mix, so you can see we're not getting up completely towards 0, and there's still a lot of dynamic range. So we've left ourselves extra dynamic range that we can reduce at the mastering stage. So if I just bring up a mastered and limited version of the same track, and let's take a look at the waveform. So we can see, if I just open it up, that our peaks are pretty much at 0, and that their average levels are much, much higher. So unless you bring down the level of a commercial track that you want to compare your track to as a reference mix, it's not a fair comparison. You're only probably going to frustrate yourself. Remember, things that are louder generally tend to sound better. So you can see the average and peak levels of our master track are much, much higher. Okay, so let's use a couple of audio examples to illustrate the difference between RMS, or average levels, and peak levels. So remember, the level meter on Ableton tracks is a peak meter. So what I want you to do is listen to these two tracks and tell me subjectively which feels the louder to you. So as humans, we're more interested in how things feel. We have a subjective response. So here's sound one, and watch the peak meter. So a guitar being plugged in. Don't do it with your speakers on. Now sound two, our piano chords. So you can see now we haven't reached zero with this, so our peak level is actually less, but I'm sure you agree that the piano track on average sounds louder. So we have a problem with DAWs. They don't seem to offer many tools for RMS metering. Thankfully, there are several free or very cheap tools out there that we can use. So let's have a look at one. So this is called TT Dynamic Range Meter. It's for free. You just look it up on the internet, you'll find it. So it has a lot of very handy tricks up its sleeve. So we got a peak meter, a dynamic range meter, and an RMS meter, all in one plugin. So on the outsides, we can see our peak level moving quickly. On the inside, we can see our average level. And right in the middle, we have our dynamic range meter. So TT Dynamic Range Meter gives you a lot more useful information than is possible just with the peak meter in Ableton. So previously I've talked about 0 dB digital and how it's similar to aiming for the edge of a cliff. So how about if we had a better zero to aim for? So VU, and it's in VU meters, so that's a voltage measurement, is directly linked to your sound card. Now you'll find if you're in Europe that will probably be a figure of -18, which is the calibration point, or in North America it will probably be around -20, but you'll have to check the manual of your sound card. So I'm going to use a 1 kilohertz test tone, -18, and you can see I have it set to -18 on, this is called VUMT from Klanghelm, it's €8. If I move that around, you can see we're on our 0 point, same with the TT Dynamic Range Meter. The second VU meter we have, and see that VUMT has a trim pot as well, very handy. So our second VU meter is from LSR Audio, and that has one little quirk with the calibration. So you'll see if I bring it down to -18, we will still be 3 dBs shy. That's because of the pan law in Ableton, which is -3 dB. So if I drop the calibration by another 3 dB, we'll be on 0. Now this is not just some gimmick to make you feel like you're in an analog studio. This is because you want to get the most out of your sound card. If your sound card is calibrated to -18 or -20, that's the sweet spot of your sound card. So if you keep your average level around there, and particularly for recording, that gets the absolute maximum quality out of your sound card. So if we see with a piece of audio running through, we can see on our peak meter we're just going over -12. And then you can see on our two VU meters, we're hovering around the 0 point. So doing this has many advantages. One is any VST plugins will work better. They don't appreciate being fed excessive level. The same is particularly true of external hardware. So you'll be running out at a correct level so you won't have any clipping or other signal flow problems. So this has been quite a complex and involving tutorial, so let's just do a quick recap just to make sure you're clear about all the various points. So 1. The peaks on your loudest track should not exceed -10 dBs. This ensures there is no clipping and it gives you headroom. 2. Peak meters are for safety only. They don't give you any musically useful information. 3. When mixing, don't try and compete with mastered tracks, it's not possible. If you want to use a master track as a reference mix, bring that down to a level similar to your mix. 4. RMS, or average levels, are how loud the music feels. So this is more analogous with how the human ear works and is much more musically useful. 5. VU is linked directly to your hardware or your sound card, so you need to check the manual and check what the correct calibration point is. As I've said, -18 is most common in Europe, -20 is most common in North America. 6. Once you've calibrated your system, you aim for 0 VU, and just like in an analog system, peaks can safely go over that level by, in either case, 18 or 20 dB. So you have 18 or 20 dBs of headroom. 7. So this is your system's sweet spot, so -18 or -20, and will improve integration with other hardware processing, and will improve the quality of your mixes no end. If anyone has any questions, please drop me a line, waveforumtraining@gmail.com. I'll see you in the next video. Thanks very much.